Okay, think about this for a second. Imagine your local gas station, right? Suddenly jacks up its prices by, say 20%. What do?
Drive down the street, probably.
Exactly. You just go to the
Yeah.
next one. But now, picture your local water company doing the same thing. Bam, 20% price hike.
Uh-oh. Not much you can do there.
Right. You'd complain, maybe cut back on watering the lawn, but you can't just, switch water providers.
Nope.
That huge difference in reaction. That's exactly what we're diving into today. Firms in competitive markets.
Yeah, this is fundamental stuff.
This deep dive is really all about understanding how businesses work, how they make decisions, how they survive, really, when competition is fierce. We'll be drawing heavily from Chapter 14 of Mankiw's Principles of Microeconomics.
And our goal here is to unpack how these competitive firms behave. We'll look at, how they figure out what to produce, how they price things, or rather how they take prices, and basically how they make it work in the market. By the end, you should have a really solid grasp of the forces behind those market supply curves we always talk about, all pulled directly from Mankiw.
Okay, great. So let's start with the basics. What actually makes a market competitive? What does that mean?
Well, a competitive market, or sometimes called a perfectly competitive market, it really boils down to two main things.
Okay.
First, you need lots of buyers and lots of sellers, many participants on both sides.
Right, loads of them.
Second, the goods being offered by all those different sellers, they have to be largely the same. Think about milk.
Milk. Okay, good example.
You've got tons of dairy farmers, tons of people buying milk, and 1 gallon of milk is pretty much like any other gallon of milk, right?
Pretty much identical, yeah.
So because of those two conditions, lots of players and identical goods, any single buyer or seller is just a tiny drop in the ocean.
Too small to make a difference.
Exactly. They have basically zero impact on the market price. We call them price takers.
Price takers.
They just have to accept the price the market determines. If one dairy farmer tried to charge more for their milk,
People who just buy from someone else.
instantly, yeah. So they take the market price.
Okay, makes sense.
Now, there's sometimes a third condition mentioned, which becomes really important later on, especially for the long run.
Oh, what's that?
It's that firms can freely enter or exit the market.
Ah, okay. So easy to start up a dairy farm, easy to close it down, relatively speaking.
Relatively, yes. This free entry and exit isn't strictly needed for a firm to be a price taker, but it's a powerful force that shapes how the market evolves over time.
And why start here with these perfectly competitive firms?
Two big reasons, really. First, they're simpler to understand because we don't have to worry about them setting prices. They just react.
Got it.
And second, they give us a really important benchmark for efficiency. It helps us evaluate other market types later on.
Okay. And you mentioned supply curves being linked to costs. Which costs are we talking about?
Good question. We're about to get into that. It ties directly into how these firms make money.
All right, let's use the example from the book, The Vaca Family Dairy Farm. How does a firm like this actually earn revenue?
Okay, so for Vaca Farm, their total revenue, TR, is super straightforward. It's just the price P of milk times the quantity Q they sell.
P times Q. Simple enough.
But the key here for a competitive firm like Vaca is that the price, P, is fixed by the market. Let's say it's $6 a gallon.
Okay, $6.
That price is $6 whether they sell 10 gallons or 1,000 gallons. So their total revenue is directly proportional to their output. Double the milk, double the revenue.
Right, because the price doesn't change when they sell more.
Exactly. Now, if we want to know how much revenue they get per gallon, we look at average revenue.
AR, which is just a total revenue divided by quantity, right? TR over 2.
Exactly. And here's a neat thing. For any type of firm, competitive or not, average revenue always equals the price of the good.
Always.
Always. If TR is P times Q, then TRQ is just P. So if milk is $6, AR is $6.
Okay, got it. And there's another revenue concept, marginal revenue.
Yes, marginal revenue, MR.
The bar.
This is crucial. It's the change in total revenue you get from selling one more unit. So the extra revenue from selling 1 additional gallon of milk.
And for our competitive Vaca farm.
Here's the really important insight specifically for competitive firms. Because the price is fixed at, say, $6, selling 1 more gallon always adds exactly $6 to their total revenue.
So for them, marginal revenue is also $6.
Bingo. For a competitive firm, marginal revenue equals the price of the good. PAR equals MEBR. This simplifies their decisions a lot.
Okay, so PSAR equals MER. That's a key takeaway for competitive firms. Now the big goal, profit, Total revenue minus total cost.
Yeah.
How do they maximize that?
Right, that's the ultimate aim. How does Waka Farm figure out the best quantity of milk to produce?
Yeah.
They use that principle of thinking at the margin. It's not just about total profit. It's about comparing the extra revenue from one more unit, MR, with the extra cost of producing that unit, which we call marginal cost, MC.
Okay, comparing MR and MC.
Exactly. Let's say MR is $6, the price. If the MC of producing the next gallon is only $2...
Definitely produce it. Profit goes up by $4.
Right. But what if the MC of the next gallon after that is, say, $7?
Don't produce it. You'd lose $1 on that gallon.
Precisely. Producing it would actually reduce your total profit.
So it's all about that comparison at the edge, at the margin.
That's it. And this leads to 3 sort of golden rules for maximizing profit.
Okay.
1, if MR is greater than MC, make more, increase output.
Makes sense.
2, if MC is greater than MR, make less, decrease output. And 3, where do you end up? You keep adjusting until you reach the point where marginal revenue equals marginal cost, MR equals MC. That's the profit maximizing level of output.
So that MR-MC point is the sweet spot.
It's the equilibrium for the firm, yes. Now let's visualize this a bit. Think about the firm's cost curves. You've got an upward sloping marginal cost MC curve.
Right. Cost usually rise as you produce more.
And for a competitive firm, the market price is just a horizontal line, right?
Yeah.
With their price takers.
Okay, horizontal line for price, and that's also their MOR.
Exactly. P equals MAR. So where does this horizontal price MR line cross the upward sloping MC curve?
That intersection point. That must be where MR equals MC.
That's it. That intersection tells the firm the quantity, QMAX, it should produce to maximize its profits.
And what if the market price changes? Say it goes up.
Good question. If the market price rises, that horizontal PMR line shifts upwards. Now, at the old quantity, MR is suddenly higher than MC.
So rule 1 applies, increase output.
Right. The firm will increase production, moving up along its MC curve until it hits the new higher intersection point where the new price equals MC.
Okay, so the amount they supply changes directly based on the price, following their marginal cost curve.
You've got it. And that's the massive insight, because the MC curve shows how much the firm will supply at any given price. Since PMR and they produce where MRMC, the competitive firm's marginal cost curve is its supply curve.
Wow, okay. The MC curve is the supply curve. But you mentioned caveats. Short run, long run stuff.
Yes, exactly. There are some really important distinctions here, especially when prices get low. We need to talk about shutting down versus exiting.
Shut down versus exit, what's the difference?
A shutdown is a short-run decision. It's temporary. The firm stops producing for a while, maybe because the market price is really low, but it still exists. It still has to pay its fixed costs like rent or maybe loan payments on equipment.
So like closing a seasonal ice cream stand for the winter.
Perfect example. They shut down, but they plan to reopen. They still have the building, the freezers. Those are fixed costs that they pay even when closed. An exit, though, is a long-run decision. That's leaving the market for good.
Selling the ice cream stand, getting out of the business entirely.
Exactly. Selling the land, getting rid of the equipment. You avoid all costs, fixed and variable, because you're just gone.
Okay, so shutdown is short-run temporary, exit is long-run permanent. What makes a firm decide to shut down in the short run?
The rule boils down to covering your variable costs. A firm should shut down if the total revenue, TR, it gets from producing, is less than its variable costs, VC.
Shut down if TRVC. Can we simplify that?
Yes. If you divide both sides by the quantity Q, you get shut down if price is less than average variable cost, AVC.
AVC. Okay. Why only variable costs? What about those fixed costs they still have to pay?
Because those fixed costs are unavoidable in the short run. Whether they produce or not, they have to pay them. So the decision hinges on whether the revenue they get from producing at least covers the extra variable costs incurred by producing.
Right. If the price per unit doesn't even cover the cost of ingredients and labor for that unit, you're losing even more money by staying open than if you just shut down and only paid the fixed costs.
Precisely. If P is less than AVC, producing adds more to your costs than it adds to your revenue. Better to just stop producing temporarily.
So this means the firm's supply curve isn't the entire MC curve.
Correct. The competitive firm's short-run supply curve is only the portion of its marginal cost curve that lies above its average variable cost curve. If the price falls below AVC, they supply zero.
Okay, MC above AVC for the short-run supply. This brings up the idea of sunk costs, doesn't it? Like those fixed costs in the short run.
Exactly. A sunk cost is a cost that's already been committed and you absolutely cannot get it back.
Like spilling milk. You can't unspill it.
Perfect analogy. Or buying a non-refundable concert ticket and then getting sick. The money's gone.
And the lesson for decision-making.
Ignore sunk costs.
Yeah.
Seriously, they're irrelevant to future decisions because you can't change them. They're in the past.
So those fixed costs, being sunk in the short run, shouldn't influence the shutdown decision. The rent has to be paid whether the ice cream stand makes ice cream or not.
That's the logic. The only relevant costs for the shutdown decision are the variable costs you can avoid by not producing.
You mentioned a movie ticket example.
Right. So you bought a $10 ticket, lost it. That $10 is sunk. Now, should you buy another $10 ticket? The decision depends only on whether seeing the movie is still worth at least $10 to you now. The lost ticket is irrelevant.
Okay. And this explains why we sometimes see businesses open with very few customers, like off-season resorts or restaurants during slow hours.
Yes. The rent, the building, maybe some core equipment, those costs are sunk. As long as the revenue they get from the few customers they do have covers their variable costs, like the food ingredients, electricity used, maybe one extra waiter, it makes sense to stay open. They're minimizing their losses compared to shutting down completely and still paying all the fixed costs.
Okay, that clarifies the short run. Now, what about the long-run decision to exit?
In the long run, all costs are avoidable because the firm can choose to leave the market entirely. So the decision rule changes.
How so?
A firm will exit the market if its total revenue, TR, is less than its total cost, TC. If it's consistently not covering everything, it's time to go.
Exit if TRTC. And simplifying that by dividing by Q.
You get exit if price is less than average total cost, ATC. Remember, ATC includes all costs, fixed and variable, averaged per unit.
So PATC means exit,
right?
And presumably PATC means?
Potential new firms will see an opportunity for profit and decide to enter the market.
Okay, so entry happens if PATC, and this affects the long-run supply curve.
It does. The competitive firm's long-run supply curve is the portion of its marginal cost curve that lies above its average total cost curve. If the price is sustained below ATC, the firm will eventually exit, supplying zero in the long run.
And can we see profit or loss on these cost curve graphs?
Absolutely. Remember, profit equals TRTC. We can rewrite that as TRQ, TCQ.
Which is PATCQ.
Exactly. Profit equals price minus average total cost times quantity. So on the graph, if the price line is above the ATC curve at the profit maximizing quantity, where PMC...
P is greater than ATC, so PATC is positive.
All right.
And the total profit is a rectangle with height, PATC, and with Q.
And if the price line is below the ATC curve?
Then P is less than ATC, key ATC is negative, and the firm is making a loss. The loss is represented by a rectangle with height, ATCP, and with Q. In this situation, the firm would plan to exit in the long run. Okay, that's a lot of rules. Let's try that Fred and Wilma recap from the chapter to nail it down. Fred is the partner, Wilma the expert.
All right, I'm Wilma.
Okay, Fred asks, Wilma, how much output should we produce to maximize profit?
Fred, we produce where price equals marginal cost.
Fred, okay, but will we make a profit doing that?
Yes, Fred, if price is greater than our average total cost, if price is less than average total cost, we'll make a loss.
Fred, uh-oh, a loss. Should we keep operating in the short run, though?
Only if price is greater than our average variable cost, Fred. That minimizes our losses. If price falls below average variable cost...
Then shut down temporarily.
Yes. And if the price stays low, we'll plan to exit in the long run.
Fred, so just to be clear, short-run supply is the MC curve above AVC, and long-run supply is the MC curve above ATC.
You got it, Fred. Exactly.
Perfect. That really summarizes the individual firm's decisions. Now, let's zoom out. How do we get from one firm's supply curve to the market supply curve?
Okay, let's consider the short run first. Here, the number of firms in the market is fixed. Let's say there are 1,000 identical dairy farms.
1,000 vacus.
Right. We know each farm's short-run supply curve is its MC curve above its AVC. To get the market supply curve, you just horizontally sum up the quantities supplied by all 1,000 firms at every possible price.
So if it's $6, each farm supplies 100 gallons. The market supply at 6 is 100,000 gallons.
Precisely. You just add them all up side by side, graphically speaking.
Okay, that's the short run. But you said the long run is more dynamic because firms can enter and exit.
Exactly. The long run is where things get really interesting. Remember, firms will enter if they see existing firms making profits, PATC, and they'll exit if they see losses, PATC.
This entry and exit must affect the market price and supply, right?
Absolutely. If firms are making profits, new firms enter. This shifts the short-run market supply curve to the right, increasing the total quantity supplied and pushing the price down.
And if firms are making losses?
Some firms will exit. This shifts the short-run market supply curve to the left, decreasing a total quantity supplied and pulling the price up.
So where does this process stop?
It stops when there's no more incentive for firms to enter or exit. This happens when firms remaining in the market are making zero economic profit.
Zero economic profit again.
That means price must exactly equal average total cost. P equals ATC. If P were higher, firms would enter. If P were lower, firms would exit.
But wait, firms also maximize profit where P equals MC?
Correct. So if in the long-run equilibrium we need P equals ATC due to free entry exit, and firms choose P equals MC for profit maximization, then it must be true that MC equals ATC.
MC equals ATC. Where does that happen on the cost curve graph?
That only happens at one specific point, the very bottom, the minimum of the average total cost curve. This is called the firm's efficient scale.
So in long-run competitive equilibrium, firms are forced to produce at their most efficient level.
Yes. The combination of profit maximization and free entry exit drives them to operate at the minimum point of their ATC curve.
And what does this imply for the long-run market supply curve?
If all firms have identical costs and inputs aren't scarce, then the long-run market supply curve is horizontal, perfectly elastic, at that minimum average total cost price.
Horizontal. Why?
Because if the price were any higher, firms would flood in, driving it back down to min ATC. If it were any lower, firms would leave, driving it back up to min ATC. The market can supply any quantity in the long run at that specific price simply by adjusting the number of firms.
Okay, but let's revisit that zero economic profit thing. It still sounds weird. Why stick around for zero profit?
Remember the difference between economic profit and accounting profit. Economic profit includes opportunity costs.
Right, what the owner could have earned doing something else, or the return on their own invested money.
Exactly. So zero economic profit means the firm's revenue is covering all costs, both the explicit ones like wages, materials, and these implicit opportunity costs.
So the owner's getting paid for their time and their investment. It's just counted as a cost in economics.
Precisely. An accountant might look at the books and say, wow, you made $80,000 in accounting profit. But the economist says, yes, but your opportunity costs were also $80,000, so your economic profit is zero.
And that's enough to keep them in business because they couldn't do any better elsewhere.
That's the idea. They're fully compensated.
Okay, let's put this long-run adjustment into action. What happens if there's a sudden shift in demand? Say that miracle milk discovery we mentioned.
Okay, picture this. Panel A. We start in long-run equilibrium. Market price is P1 equal to the minimum ATC. Firms are making zero economic profit. Quantity is Q1.
Stable situation, then boom, demand shifts out because milk is amazing.
Right. Panel B, the short-run response. The demand curve shifts right, D1 to D2. With the number of firms fixed, the price shoots up to P2. Market quantity increases to Q2 as existing firms move up their MC curves.
And crucially, at this higher price, P2, P is now greater than ATC.
Exactly. Existing firms are making positive economic profits.
Which acts like a signal, right?
A huge flashing neon sign. Panel C, the long-run response. Those profits attract new firms to enter the dairy market.
More firms means more supply.
Yep. The short-run supply curve starts shifting to the right, S1 towards S2. This increase in supply pushes the market price back down.
All the way back down.
In this simple case with identical firms, yes. Entry continues until the price falls all the way back to the original level, P1, where price once again equals minimum ATC.
So profits are competed away back to zero.
Back to zero economic profit. But look what happened. The total market quantity is now much higher, Q3, because there are simply more firms in the market, each producing at its efficient scale, minimum ATC.
Fascinating. Entry drove the price back down, but increased overall supply. But you hinted that the long-run supply curve isn't always horizontal.
Correct. That perfectly elastic horizontal curve relies on assumptions that might not always hold. There are two main reasons the long-run supply curve might slope upward.
Okay, what are they?
Reason one, limited resources. Some inputs needed for production might be available only in limited quantities. Think fertile farmland for growing a specific crop.
Right. You can't just create more grade A farmland instantly.
Exactly. So if demand for the crop increases, more firms try to enter, bidding up the price of that limited farmland. This raises the costs for all firms in the market.
So their ATC curves shift up.
Right. And if costs are higher, a higher market price is needed to make production profitable and encourage that increased supply. So price has to rise to get more quantity and upward sloping long-run supply curve.
Okay. Limited resources raising costs. What's the second reason?
Reason 2. Firms have different costs. Maybe some potential entrants are just less efficient than existing firms. Think painters, some are faster or have lower opportunity costs than others.
Yeah, not everyone is equally skilled or has the same alternatives.
So as the market price rises, it might first attract the low-cost, efficient painters. But to get even more painting services supplied, the price might have to rise high enough to entice higher-cost painters to enter the market too.
So you need a higher price to bring in the less efficient firms.
Exactly. In this case, the long-run market supply curve will slope upward. Interestingly, the marginal firm, the firm that would exit if the price fell any lower, earns zero economic profit. But those lower-cost, more efficient firms who entered earlier, they might earn positive economic profit even in the long run.
Okay, so limited resources or differing costs can make the long-run supply curve slope up.
Huh?
But is it still flatter than the short-run curve?
Oh, absolutely. The long-run supply curve is almost always more elastic, flatter than the short-run supply curve. That's because firms have much more flexibility in the long run. They can fully adjust, enter, or exit. Short-run supply is constrained by the fixed number of firms.
Got it. So wrapping this all up, what's the big picture takeaway from this deep dive into competitive markets?
I think it really underscores the power of marginal thinking, how firms constantly compare costs and revenues at the edge.
Yeah, that MRMC rule is central.
It is. And it reveals something profound. In these competitive markets, the price consumers pay tends to gravitate towards the marginal cost of producing that good.
IMC.
And with free entry and exit, it also gravitates towards the lowest possible average total cost at efficient scale. It's a really powerful mechanism driving efficiency.
So understanding this helps us make sense of why things cost what they do and how businesses react in industries where there's lots of competition, like agriculture or maybe basic commodities.
Exactly. It gives you a lens to see the underlying economic forces shaping the prices of everyday items and the behavior of countless firms.
It really makes you appreciate the dynamics.
It does, and it naturally leads you to wonder, well, what about markets that aren't like this? What about firms that do have power to set their own prices?
Like monopolies or maybe firms with strong brands?
Right. How do they behave? But that's definitely a deep dive for another time.
Indeed it is. Well, thank you for joining us on this exploration of competitive firms, guided by Mankiw's insights. We really hope this shortcut helps you feel well-informed and maybe even sparks more curiosity about the economic world all around you.